Hello dear students, this is Science, Unit 10.4, 10.5, 10.6, Electric Current. You can find this information on page 146 to 150. As usual, objectives, definition, and then what is conductors and insulators and what is the circuit diagram. And then we go electric cell and the current. Definition. What's electric current? Electric current, when I say what's an electric current, is an energy that flows in a closed metal circuit. Where is the metal circuit? I mean this wire here, okay? Which produces from where comes this energy? It comes from the battery. So this is here is a normal symbolic electric circuit, and this is how it looks in real life. So this circuit is electric symbolic, where we do it in technical drawings, and this one is in the real life. So the light pump represented by this light bulb here, and this is the switch. It will be represented in the electric design, something like this, and the battery will be represented something like that, and the wire, of course. So the battery here produces energy, okay, which goes out, which we call it electric current, which goes out from the positive pole going around the circuit, so that the light bulb will be lightened because of this electric current, which carries energy. If the switch is open, the current will not flow, okay, because the current have to flow from positive and comes back to negative, so that it can be energized and the light bulb can be activated. If it is open, then the circuit is open, so there is no current flow in the circuit. Only when you close the switch, then we have a current flow in this circuit. This is also the same circuit here, but we have here three sources. That means we have more current because we add them together. For example, if this one is 1.5, so this one is plus 1.5, plus 0.5, 4.5. So we have more electric current. The light bulb will be lightened more also. What is that here? Is a resistor. The resistor represents the resistance of the light bulb to the current going through it. Every device you put in an electric circuit, will resist the current that flows through it, and we represent this resistance by something like that. You see this symbol here? This is resistor, is written here, resistance of the lamp to the electric current. This is representing the resistance of the lamp. These are not two devices. No, they are one device, but we represent the resistance outside by something like that. Also, by the way, the battery represents a resistance, but a very small resistance. It should be also represented here, but they didn't put it in the circuit. This is no problem for your lesson, but only to know that the battery also have a resistance against the current, and the load, which is now is the light bulb, also have a resistance against the current that passes through it. Okay, now we go to another subject: conductors and insulators. Conductors are materials that allow current to flow through them. Insulators are and the opposite of that. They don't allow current to flow through them. A very obvious question that may come in this subject is: list two conducting materials and two insulated materials. You can say two conducting materials like silver and gold, two isolated materials like wood and fabric or plastic. Okay, this is a very obvious, but the question is here also: why conductors allow current to flow through them, and why these? How can you explain this for me from the atom point of view? I will tell you that they are very good conductors because for certain they have electrons in the outer orbits which are not attracted very strong to the nucleus of these materials, and when they are exerted to an outer force, they will leave the orbits very quickly. That's why they are very good conductors, because they can produce free moving electrons very quickly when they are exerted to outer force. And the opposite is by these insulators. They have electrons in the outer orbits which are very, of course, outer orbits or outer shields. They are very attracted to the nucleus of the material, and they need a very big outer force so that they get loose from these orbits. So they are really not, they cannot produce a lot of free electrons, which are the symbol of electric current. When they don't produce a lot of electrons, then that means that the current cannot move. They are very bad conductors, or you can say they are isolators. Okay, this is the explanation why they are good conductors and why they are bad conductors or isolators. Now we go to the electric circuit diagram. If I ask you to draw an electric circuit diagram, this is an electric circuit diagram. This is a wire. Of course, this wire must be a conductor or isolator. It must be a conductor because I need a wire that produces for me free electrons so that the energy can move from one place to another. And we have this battery and the switch and the light bulb. Okay, this is a simple electric circuit or circuit diagram, and we call these things, the switch and the battery and the light bulb, we call them all the circuit components. The circuit components, these are the circuit components: the battery, the switch, the light. So if I ask you, please list the circuit components that you see in this circuit diagram, you say to me battery and switch and light and wires. Okay, now we come to the electric circuit and the current. What I like you to know from the circuits here, what is the ammeter and what's the voltmeter? Ammeter is a device to measure the current which is flowing in the circuit. The voltmeter is a device which are used to measure the potential difference across the device or across the load which is connected to the circuit. Okay, this circuit here shows you that from the positive, the red one here, the red one is the electron direction, and the current direction comes from positive. Then this is negative and this is positive. The current direction goes from positive to negative, but the electron directions, they goes from negative to positive. Why? Because the polarity here is negative, and we have free electrons also negative, and we know that two alike charges, they repel from each other. So these electrons here, the electrons in the wire, will be repelled from the negative polarity of the cell, so they will move in this direction. But the electric current moves from positive to negative. So this is if a question can come like, list the circuit what is the circuit components here? What you see, you say to me a cell, an ammeter, a voltmeter, and a resistance. These are the components of this circuit. What is the components of this circuit? A lamp and a cell. That's all. The components of this circuit is a lamp and a cell, and the components of this circuit is a cell, an ammeter, a voltmeter, and a load. You can say a load or a resistance. We can say also a lamp, because I think this resistance represents this lamp here. End of unit question. I want you to make question 10.2, page 158. Try to make question 10.2, is very important, page 158. Thank you very much.